So we're now going to get onto our first proper tool thing, I guess, that isn't just units all over again in astrophysics, and it's the thing known as astronomical gravity. So this is also known as Newton's law of universal gravitation, which I will tend to abbreviate. Let's hope this thing doesn't or do anything weird. As Newton's law of universal gravitation as n log. So you should know at this stage that gravity is the constant downward force on planets which keeps things pinned to the ground, as long as we don't have a greater force that opposes the gravitational force. So for instance, if there's a body getting sucked out by, I don't know, some future wormhole that we find or comes near Earth, as long as that force isn't greater than the gravitational force, we'll be struck here on the ground. So Newton's law of gravitation, or gravity, however we say it, between two bodies, so the force of gravity between two bodies, directly proportional to the product of the masses and inversely proportional to the square of the distance between them. That's a bit of a long definition. I think it's better off if we do the mathematical definition, which is this. So if we let F be the force of gravity between the bodies, d be the distance between them, and m1 and m2 be their masses, then from Newton's law of universal gravitation, I included the O there, that we know the force is the product of the masses is m1, m2, and the square of the distance is d squared. So putting them together, we know that the force is proportional to these two divided times by a constant k. Now, this constant k, we don't call it k, we actually call it capital G. So you'll often hear me differentiate between big G and little g. So big G is 6.67 by 10 to the minus 11. If you want, you can figure out the units dimensionally. Uh, you can verify this, but if I remember correctly, the units for G are Newton meters squared per kilogram squared, I think. I could be completely wrong. Tell me in the comments if I'm wrong, but those should be the units. Newton meters squared per kilogram squared. And we're going to do a little example on utilizing this law.